a break, and some of you guys were out on Friday. So we learned how to solve systems by graphing. We will kind of review that like as the unit goes, but if you were absent, who was absent? You, and Cruz. But you got caught up, right? Sort of. Okay, if you were absent, I did email you a video. Come into tutorials, we can go over it. It's easier than missing today or the rest of the week, but anyways, it is important. Oh yeah, Miles, you were gone too with wrestling, weren't you? So we definitely need to make sure that we are catching up with that a little bit. We didn't do page 10, so we're actually going to start there and kind of just talk a breakdown of doing solving by graphing in our notes, and then we'll move into some new stuff. So this week, really, we're learning like some big lessons here. 2 methods of solving we'll do today, one, and then one on Thursday. But then really after that, you've kind of learned all the material, and we'll spend almost 2 full weeks putting it all together, practicing it, having some interventions if we need to, but most of the content's going to be taught this week. It is a lot. The problems take a little while to do. We know that, but we just got to break it down and power through it, and we'll get there. So solving by graphing, for those of you that were here, hopefully this is a refresher. If you were gone, again, this is just an intro, and we'll work in tutorials to catch you up. But just to review, when we're solving systems in general, okay, we are trying to find the place that the lines cross, the point of intersection. Graphically, like we see that actual point on there, but there are 3 types of solutions we can have, okay? Normally I'm going to have you guys do this, but since it's been Thanksgiving break, we'll do it together. So the first type that we had, I'll go back to my page and see if y'all can remember. We filled this in, so we said solving systems means finding the point that the lines intersect or cross, and there was 3 cases. We had a case where the lines crossed at one point, and we would have one solution. We would have lines that were parallel, they never crossed, so we said those had no solution. And then we would have lines that were the exact same, and they would have all or infinite solutions. And we're going to see all 3 of those cases today. So that's kind of what we want to put here. What are the 3 types of solutions? You can have a one solution case, which means you have 2 lines that cross. And this was our most common. In last class, we would actually put these lines, here's an example, and then they cross right there. There's our solution point, okay? And that's what we found in our calculator. We graphed them on a grid and plotted the point. And there's a couple different ways that we could do that. But one solution is your most common one. But then we kind of had our special cases, which we'll start to see today. Ones that would have no solution, which again means they never ever cross. And we know parallel lines. We know 2 things about parallel lines. They have the same slope, but then the other thing is that they never cross. So that would be no solution. It's one of our cases. And y'all have a test question that's like this. What are the possibles? And then you draw a picture and tell. So it's kind of it should be an easy one, but you got to remember. And then the last case was when you had all or infinite. I will accept either of those solutions, which that means that every single point is the same. They share all the points, which means they are the exact same line, okay? So graphically, we'll just draw one line, and then I'm going to kind of try to draw over it, maybe dash so we can recognize that it is 2 graphs, but they share all the same points. The equations are identical. They're probably not going to look identical, like one might be in slope-intercept, one might be in standard, but when you do graphing, substitution, or elimination, you'll realize that the equations are the same. So these are the possibilities, and there's 3 methods. We've learned 1, and we'll learn 1 more today and 1 more next class. But when we're graphing, when should you use the method of graphing? Again, this is a review from last class. So it's easier to do it in graphing when both of your equations are in what form? Very good. When both equations are in slope-intercept form.
So how do we know slope-intercept form?
Y equals M.
So when you see y equals, right? See y equals mx plus b. That's that slope-intercept form.
So when they're both there, that would tell me, both equations, that would tell me, hey, I probably should graph, okay? Sometimes they, technically, you could convert any equation to slope-intercept form, but sometimes doing that, they just get kind of yucky. You got fractions, you got things like that. So I typically only do graphing if they're both in slope-intercept form or if they're easily converted. And then one thing that was new that we learned last time is how to put your graphs in your calculator and calculate the intersection point from there, which again, if you were gone, just write down the steps, but we need to go over this in tutorials, okay? So the first step was to convert to slope-intercept form if needed. And I'm going to put that in parentheses, if needed. You may not need to do that if you're doing graphing. Hopefully it's kind of already like that. Then you type your functions in Y1 and Y2. And I'll probably make up an example. We can try an example here in a minute with that. So you put your equations into Y1 and Y2 in your calculator. And then you graph them. So let's do an example while we're going through this. All right, Cruz, give me an equation in slope-intercept form. Any numbers you want.
Y equals 3/4 x plus -2.
Can I put -2? Yeah. Okay. All right, so there's 1. 3/4 x minus 2. Ethan, give me a slope-intercept form. With a negative slope. With a negative slope.
-1/2 x minus 3.
All right. Can I do +3? You okay with that?
Okay.
I think it might make it a little bit prettier, but we'll see. Okay, so here's an example, and who knows? This is probably going to be crazy decimals because we just made it up, but I love the fractions here on this Tuesday morning after break. So we already are in slope-intercept form, so we didn't have to do step number 1. So for those of you that were gone, here's what we did. We would put our equation in Y1 and Y2. So we would put in Y1, 3/4 x, oops, not 34, 3/4 x minus 2. In Y2, we would put -1/2 x plus 3. And we type them both in. If you need help typing in the calculator, please ask. Make sure you're doing it with us. Y1 and Y2. You get a thing? And then we want to hit graph after that. And look at the graph. And so when you look at your graph, you should have a picture, one of the 3 options that we drew above. You're either going to have lines that cross, lines that are parallel, or the exact same line. And with the colored calculators, it's really nice because you'll see like one's a blue, one's a red. Okay? And so I can tell right now that these lines are going to have how many solutions? 1, because they cross 1 point. Okay? Again, that's our most common case. So we good here so far? We see our 1 solution? Yes? Yes, 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 yes. Okay? All right, so here's how your calculator can find it. Go back to step number 4. Let's write this down. You're going to press second and then trace. Let me show you where those are as a reminder. Second is the blue button up at the top. Trace is next to graph. Are you doing this in your calculator? Yes, ma'am. Second trace. And then if you look at this, it is number 5. Remember what you're trying to find. We're trying to find the point of intersection. And when you press second trace, you're going to see an option that says intersect. So that's what we're looking for. Second trace 5. So we choose number 5. Oops, not number 6, number 5. So press enter on that. And then on your screen, you're going to press enter 3 times from there. So your calculator at the bottom is going to say first curve, enter. Second curve, enter. Guess, enter. And then your answer, oh my goodness, look at that. That was a pretty one. Good job picking those equations. Okay? Your answer will be found when it says intersection, x equals this, y equals this. And that is your solution point. So second trace 5, and then we hit enter 3 times. 3 times. And then the intersection point is the solution. I don't really know what the 6th step is, but we'll go like this. So our solution here would be 4, 1. We got lucky. Got a pretty one. Okay. So that was a very brief outline of what we kind of worked on last class. We did more examples, obviously. So, again, if you were out, I got tutorials first half today. I'm not going to be here tomorrow, but try to come in before the end of the week and try to get caught up. Got that? Absent people? Got that right here? Okay. All right. So here is on page 11 a warm-up for you to do. Has to do with some graphing and writing a word problem, and I'm going to give you guys a minute to look through that. And most of you guys ended up coming around and getting the first question. I'm going to put a star by this. What does that mean? Well, it is a star question, yes, but
Might be in the test.
might be on your test. It's important, okay? It is, and I heard Coach saying this is one of the easy ones on the test because we can use our calculator. We can use multiple choice. Or we do have multiple choice, and we can kind of go through our answers. But ultimately what this is asking you to do, guys, is they gave you a graph with 2 equations. They gave you answer choices, all of which are in slope-intercept form, which is extremely good for us. And then we have to say, okay, which system matches this graph? There is a multitude of ways that you can do this. One way I saw y'all doing was you just went and you typed each equation in negative x minus 4. I'm not going to type all of them, but I'm just going to show you what some did. 2x minus 2. And just looked at the graph. And we're able to say, okay, was this the same or was it not? That is not a bad strategy. Sometimes, though, they might be kind of close, so you got to be careful. But if I look, my point of intersection on my graph, my solution is over here. Negative x, positive y. The point of intersection on this graph, is that even in the same area? No. So then this answer cannot be right. So you could do it that way. F, G, H, J. And see which one does match, okay? Option 2, I saw some of you guys looking at each line at a time and finding the slope of each line and the y-intercept of each line. The slope and the y-intercept of each line, one at a time, and then matching that way. And then the other thing that you could do was they gave you some points on each line. So my first line, I could make a little table, and I don't know if anybody did this, but it might be worth talking about. And I could put this little table in stat. Y'all remember doing stat? Stat Calc 4. And then it would give me my slope-intercept form of each line. So you could have done that with those 2 points and those 2 points. Any way you did it, what was the right answer? J. J was the right answer. I helped cruise on this one, and we looked immediately at the y-intercepts, and we saw that one of my y-intercepts was positive 4 and one was negative 4, and we threw out F and H because they did not have the correct y-intercepts. They had a y-intercept of -2 and -2, so we threw those out. And then we were just looking between 2 answer choices there. But so there's a lot of ways you could have done that. But the answer was J. Use your calculator. Use your toolkit, whatever you got. And then this last one was about candle shopping. Anyone get the answer on that one?
I got C.
C. Very good. Remember, on a lot of the STAR questions, they give you the variables. Large candles were X, small candles were Y. And then you were going through and you were just writing an equation for each person. They paid $64. They got 3 large, 4 small. And then it says the next customer paid 4 more. So what's $4 more than 64? 68. So you had to have a 68 right there. And then they got 1 large and 8 small.
Is it okay if you put the 68 on the other side?
Yeah, and that's what they did. And I don't know why I didn't do that, but either way it would be okay. Because it's an equation, so you can switch with that there.
And I worked with Ethan a little bit on that one, and he immediately said, well, it can't be, what is that, B and D? Because 60. And he's like, it's got to be 4 more. So he's like, those are wrong already. So he caught that really quick. He caught that quicker than I did. He was already like, oh yeah, mark those off. Okay, yeah, good point.
And this one they kind of disguise. Like a lot of times the problems they give you those amounts, but that one said 4 more. Okay, but we can add $4 to 64. That's not too bad. And so and that's kind of, we did writing before break as well. And so you're going to continue to see these writing problems pretty much every day. All right, now we're actually going to move to new stuff. Now we've had 30 minutes of class. And our next method that we are learning is called substitution. Okay, and it is not as scary as those 8th grade boys told me it was back in the day when I was learning this. Okay, it's not that bad. This page may stress you out. But let's review. When we find a solution to a system, here's kind of the big idea over the next few days is we are still solving systems. We're not going to really do anything in our graphing calculator. We'll have our calculator to help with numbers, but we're not going to be looking at a graph at all when we're doing substitution. But we're still doing the same thing. We're finding the point that they cross. So a solution to the system is a point, which means it's an ordered pair, an x comma y. So that's how our answers are going to look. That both lines have in common, that they share, or where the lines intersect. We already talked about that. We reviewed that. But remember, moving forward, that what we're doing today, although we are not looking at a graph at all, we are still finding that point. And the method we're going to talk about today is substitution. So we wrote on our little breakdown sheet that we did for a warm-up, we wrote when it was easier to do graphing. Here's when it's easier to do substitution. Okay, and let's write it out. It may not make sense till you see the examples, but we'll go with that. Okay, substitution is the, quote, easier route when one of your variables or one equation is already solved for or isolated. So graphing is, hey, they're both in slope-intercept form. Let's put it in our calculator and graph it. Substitution, you might have one equation in slope-intercept form because y would be isolated. Y would be by itself, but your other equation is not, okay? And it doesn't matter which equation. It doesn't matter which variable. But an example would be if you have something like x equals 4y minus 7. That's an equation that's already solved for. It's already solved for x. So I would be saying, oh, I should do substitution here. Okay? Or you could have a y equals 4x minus 7. That might be one that you would do substitution for as well. And when you see the examples, you'll kind of know what I'm talking about. But that's what we look for. That's what's catching our eye is like, oh, one equation's by itself. Let's do this method. Okay? This is a whole thing that goes through the steps. I know it's kind of overwhelming. I think after we see a few and then you go back and look at this, you can kind of follow what they're doing. But the idea is that you're going to sub in, that's why it's called substitution, for another variable, okay? And then we'll solve. So it's going to bring back our solving equations, drawing the line, inverse operations, stuff from way back when that we did at the beginning of the year. But it's kind of times 2. All right, so we've got some problems to try to go through. The first one is actually kind of a little baby step, but just to get you like warmed up to the idea. Let's flip over, and we're going to try to knock out these next 2 pages, okay? All right, so it says to solve the system of equations. So we have x equals negative 4. And we have 2x minus 9y equals 28. So the first thing is I would do substitution because if you look at this first equation, x is solved for, x is isolated. So that would tell me, hey, I should do S for substitution, okay? Y'all see that there? I'm going to put a little box around what x is equal to. Now, this problem is kind of a little baby problem because x is already equal to a number. So we already know what x is. We won't always, but this is just getting our brains warmed up. So x equals -4. Now, look at the second equation. It says 2x minus 9y equals 28. I can't do anything with that right now. There's two unknowns. But what do I know that x is? -4. So watch what I'm going to do. I want you to do this too. I'm going to draw an arrow from -4 and I'm going to point it to x, what it's equal to, in the other equation. Because they are the same. -4 is the same thing as x. And now I'm going to rewrite my second equation, but instead of writing an x, what am I going to put?
-4.
2 parentheses, sub in -4 minus 9y equals 28.
So is that it?
Oh no.
It's close. It's the right first step.
And then you solve it.
Now we need to solve it. Now are we able to actually solve for our unknown variable? Why?
Yes.
Yeah, because we can figure out what that is and move it. We can get rid of the -9 eventually. And we can solve for y. When there was a 2x in there, we couldn't do anything with that. But now we're able to just clean this up. So what is 2 times -4?
-8.
That's -8. So we're going to have -8 minus 9y equals 28. It's already looking better. Got some parentheses out of the way. Okay, and so now I'm going to draw my line. Again, this is a throwback here. We haven't done this in a while. Daniel, remember what to do next?
Yeah, you do +8.
You do plus 8 on
Both sides.
both sides. So we plus 8 here, we plus 8 here. That's going to take this guy out. I'm going to drop down -9y. 28 plus 8 is 36. You got the next step?
You divide it.
By what?
-9.
-9. Divide both sides by -9. So divide by -9, divide by -9. And this is going to simplify and give me that y equals, what's 36 divided by -9?
4.
-4. So now I have to write my solution as a point, as an ordered pair, which remember those are x comma y. So what was the x value that we already knew from the beginning? -4. And then what's the y value that we solved for? And that's my solution. So and this would be your answer. This would be what you write in on the test. Okay? So here's the thing. There are a lot of steps. The process sometimes takes a little while, but this is essentially, it's very repetitive. Like once you get the steps, they're the same ones over and over. All we do is change up the numbers. So you find your isolated variable, sub it in, solve, go back and solve. Okay? So number 2 is going to be a little bit more in depth because do you already know what one of your variables is equal to? Like just numbers straight off the bat. No. And I will warn you, it's not going to be like that on the test. This was just intro. This is more the level of what we're going with. But let's analyze our equations. X equals -7y minus 8. And then 2x minus 9y equals 30. Do y'all see how this first equation, x is solved for? X is all by itself. Do y'all see that? So I'm going to put my box around this whole thing. -7y minus 8, and that's important. It's got to go around the whole thing. That's what x is equal to. And so I'm going to do what I did on the other problem, and I'm going to draw an arrow. Where am I going to put the box? Where am I going to sub it in the other equation? Sub it in for x, what it's equal to. So this guy's going to go woo right over here. Okay? This is important, you guys. You have to know where it's going. It's going for the variable it is equal to. Are we okay?
And I would draw that arrow.
I'm kind of confused on why it would go into x versus going into y with the second.
What is the box equal to?
What's it say?
X equals.
So it's got to go in for x. And I kind of think of it as like what I just said. What is the box? I don't care what's in the box. What is the box equal to? It's equal to x. That's where it goes
Okay.
in place of. Okay? And then here's the next step. When I write it out, I'll show you how you can know you did it right. Okay? So now let's rewrite the second equation. So 2, no more x. Open up a parentheses. Brayden, what are we putting in for x? No. What are we putting in for x? What's in the box? What is x equal to?
7y. Negative.
It is negative. What's on your paper? But it's negative 7y.
Negative 7y minus 8.
Okay? And so I put it in parentheses. Okay? But I have to finish the rest of that equation. So what's the rest of that equation say, Miles? Miles? What's the rest of the equation say?
2x.
We already did the 2x.
Minus 9y
Equals.
equals 30.
Okay, so at this point, and Anya, this is what I was just talking about. If you want to know if you did it right, here is your check. Are you listening? Your variables should be the same letter. Are these the same letter?
Yeah.
So that's how I know I did it right. If you plugged in over here, you would not have the same letter. You would have an X and a Y. So this is how you know, okay? So this is the big idea, guys. This is really the only thing that is new today. But if you don't get this step right, whole thing's not going to be right, all right? So we do a quick checkpoint here to make sure we have the same letter. So I'm going to do a check mark because we have the same variable. And now I'm able just to do some algebra and solve it out. So what do I have to do on this side?
Distribute.
I have to distribute. So I'm going to multiply 2 into these guys. Do I multiply the 2 to the minus 9y? No, I do not. So I'm going to have 2 times negative 7y is negative 14y. 2 times negative 8 is negative 16. Minus 9y equals 30. Okay? It's looking better. Now, if you remember way back when we did this, after we distributed, we checked for like terms. Do we have any like terms on the left-hand side?
Yes.
Yes, both of those y's, which they have to be the same variable. So I need to put those together. Negative 14, watch the negatives here. You can use your calculator to check. Negative 14 plus negative 9 is negative 23y minus 16 equals 30. Okay, so I'm just working the problem down. Distribute, combine like terms. Now I'm ready to draw my line. I've cleaned up the left-hand side as much as I can. So now I can draw my line. Nick, what's going to move first after I draw the line?
Plus 16.
Plus 16 on both sides. And that gives me negative 23y. 30 plus 16 is... All right, Jahan, what do we do next? Final step to get y. Divide by... What's in front of y? What kind? Negative 23. So negative 23 on both sides. And that will give me that y equals... What's 46 divided by negative 23? Negative 2. Okay? Are we finished?
No.
Did we find both points in the solution? We found the y. I can go ahead and fill that in. But what do we need to go back and find? So now we're going to go back to the top. Up arrow to the top. Back to the box. This is the final step. And this is quick. What is x equal to?
7, negative 7.
Negative 7. But what do we know y is?
Is negative 2.
So we're going to sub again to solve for x. And what's nice about this is you guys can put this guy in your calculator. Negative 7 times negative 2 minus 8. Or you can mental math it. Either one works. And so x equals 6. And here's our answer. That's the whole process. That's how it's going to be on your test, is having to plug in, solve it down, plug back in, solve for the other one. Okay? It's a lot of solving. It's a lot of algebra. So I've been telling you, algebra, it's going to come back. It's going to get real. It's kind of here where we are. But the good news is that it's just the same process over and over and over again. Okay? So the only thing that's going to change is the numbers. All right, I'm going to try one more with you, and then I'm going to let you guys try 4 on your own, okay? We okay? All right, let's look at number 3. Number 3 says y equals negative x plus 7 and negative 2x minus 3y equals 16. Is one of my equations solved for and isolated?
It just takes
Yeah.
practice.
Is one of my equations got a variable all by itself? Top or bottom?
There's no
sure?
variable by
Yes,
itself?
there is.
Which one is the same?
Why?
Y. Okay, and y'all, it doesn't matter if it's X or Y. It doesn't matter if it's the top or the bottom. I need you to it doesn't always have to be this first guy. It's not this first guy over here, but you just got to look for it and find the one that says variable equals. And after the equals is where the box goes. So where does my box go?
Negative x.
Plus 7. Now, what is the box equal to this time? Y. So where are you going to draw your arrow to? The Y. Okay, so you'll start to see there's some variety on these. Doesn't always have to be x equals. Doesn't always have to be the top. We can swap it around, and we will. But you got to know where it's going. Okay? So, rewrite the bottom equation with your sub in. And then we'll check, because we're going to do this one more together.
Write it in.
And remember, you've got to make sure that you have the same variable at this step. When you look at your problem, the 2 letters in the equation need to be the same one. That's the checkpoint to make sure you did your subbing right.
Are we just writing the equation?
We're just writing the equation right now, and then I want y'all to check and make sure you subbed right.
Instead of y. We put that in. So parentheses.
So here's my check. What are both of my variables?
Negative x.
What are both of my variables? X. So did I do my subbing right? Yes.
Yep.
Yes, sir.
Why did we get rid of the y from -3?
Because our first equation was solved for y. So you're getting rid of whatever equation is solved for. The other one, x was solved for, so we got rid of the x. This equation, y is solved for, so we get rid of the y.
Instead of y.
It just depends on what we give you, Ethan. It can be either or, and it's still going to be the same thing. Okay? All right, solve it. Go through your steps. Distribute.
And then equals 16. And see how there's only one variable? There's only an x and an x. The y's gone, which means we did it right. So now we just do math.
What's a negative times a negative? Very good. So watch that. It's like distributing in the -3.
-3 times negative x is positive 3.
So we distribute.
So plus 3x.
We've usually going to have some combining to do with this, and that's a very important step. So how do I combine negative 2x and positive 3x? What's negative 2 plus 3?
1.
Do you have to write the 1?
No.
Can you?
Yeah.
You can just write x. You can write 1x. It's up to you.
So it's negative times there, that's going to be a negative, right? Cool.
And I like 1x because I don't have to divide by a 1. So that means once I get it by itself,
16.
it's all done.
Combine like terms now.
Okay?
Which ones
So
are
what'd you
like?
do next, Ethan?
Wait, almost added.
I'm right where you are. What did you do with that negative 21?
I just added it.
Added.
21.
Actually, it was
And what'd you get?
37.
X equals 37. Okay? Are we finished?
No.
I'm going to go ahead and put in my solution, I'm going to go ahead and put that. Now, it's an X, so I'm going to put it as the first number.
Is x by itself?
But then, what am I missing, Mohammed? The y. So I got to go back to the top, back to the top, and I got to find the y, which it says y equals negative, what's my x value that I solved for, plus 7. And again, I can throw that in my calculator, or I can do it in my head. What's negative 37 plus 7? Negative. Negative 30.
Does that say plus 2?
No, it says plus 7. It's from the equation. Okay. All right, I want you guys to try number 4. You can check on number 4. Your solution was negative 3, positive 1. Okay. And again, we answered a lot of questions, kind of worked through that with some of y'all. I think you're starting to kind of catch on to the process. It takes time. It takes time. That was the solution to number 4. If you finished number 8, I will let you look at it right here. If you didn't finish that, that's okay. If you got started, you can at least just kind of see. But number 8, the solution was 26, negative 19. The x value was kind of tricky on that because x is equal to negative y. So there was a negative on the outside, but then my y value itself was negative. And if you didn't type it exactly like that, it was not giving you the right answer. So you got to be careful with that because there was like a double negative, and 2 negatives make a positive. So all of these examples have been one where we got one solution, okay? They crossed at that point. And again, we didn't look at a graph at all, so it's kind of weird, but this is the point that they would cross. Now, I want to show you number 5 because this is a case where you're going to see one of those specials, okay? One of those no solutions or all solutions. So let's look at 5 real quick, okay? Another thing that I feel like Coach and I keep talking to you guys about is y'all have to know where to start. You need to be able to analyze the equation and recognize, do I have a variable all by itself? So let's just look at the top one. 4y equals. Is y all by itself in that equation? No. So I am not going to box anything on the top. Let's look at the next one. X equals. Is that variable all by itself? Yes. So where am I going to put my box?
Behind it.
Behind it, y'all. We've got to know where that box goes. Find the variable that is alone. It doesn't matter whether it's X or Y. Doesn't matter whether it's equation 1 or 2. You've got to know where the box goes. Now, where are you going? What are you subbing in for? What is the box equal to? So draw your arrow to the X. Okay? We have to understand how to start that. And after that, it's just really old skills. Okay? Now, remember, this one's going to be one that's kind of weird. So here we go. 4y equals 2, open parentheses. What am I subbing in for X?
6 plus 2.
6 plus 2y minus 12. Are we all in terms of the same variable? Check, check. Y, y. Okay? Only one variable now. Do I need to do anything right now to the left-hand side? No, I'm going to drop it down. What do I need to do to the right-hand side? Distribute. 2 times 6 is? 2 times 2y is? Positive 4y. So I need to have a plus sign. And then what's at the end? That just drops down. Minus 12. So I distributed. Okay. What happens on the right-hand side now? What do I have to clean up? Combine the like terms, which are 12 and negative 12. But what is 12 plus negative 12? 0. Okay, so those are going to cancel out. And so what's left? 4y equals 4y. It's kind of weird, right? So what should we do now?
My head. I simplified.
Okay, we could divide both sides by. What are we dividing both sides by?
4y.
No, you don't divide by, you're just dividing by 4.
You get one line.
And so you get y equals,
1.
no,
Did you?
y equals
Why?
y.
But when it counts
Y equals what? Y.
Y equals 1.
No, it's not y equals 1. It's y equals y. What do we normally want to do when we have variables on both sides? We want to move them to the same side. Okay, so y'all wanted to divide by 4, so I did that. That's fine. You don't have to do that. But we want to move them to the same. But here's what I also want you to recognize. Y equals y. Is that true?
Yeah.
Is 5 equal to 5?
Yeah.
Yeah.
Is negative 6 equal to negative 6?
Yes.
Is x equal to x?
Yep.
Yes.
Yes. So if you get a true statement completely, what does that mean? It's infinite solutions. Infinite
Anything else?
solutions. So you don't have to do anything else. You could move it. If you moved it over, you would have 0 equals 0, which is true. So this is, again, it's one of those weird cases that sometimes that can happen. But if you're left with a true statement, like the left and the right are identical. I could have done that with 4y equals 4y and notice that it was identical there. That means it's going to be infinite solutions. These two equations are the exact same line. They don't look like the same line, but they're the exact same line.
I got a question.
Yeah.
Would it still be infinite if one of the 4's was negative?
No.
I don't think so.
They have to be exactly the same. Okay, look at 6 real quick. What are both equations on number 6 in?
Y equals.
So we're not going to do substitution. What are we going to do? If they're both in y equals, what are we actually going to do?
Oh, use that. You
Y
see
equals
Y.
graph.
We're going to graph them. Let's just do this real quick so you can see an example of this. Okay, so go to your calculator. We're going to graph them. We're going to go little rogue here. We're going to graph them. So what are we going to put in y1?
8 minus x.
8 minus x. What are we going to put in y2?
Negative x
minus 5.
equal, or negative x minus 5.
And you need to type it exactly how you just said it. Negative x minus 5. Look at your graph.
They're parallel.
Wow.
Ooh, it's no.
No solution.
No.
No solution. Very good. Why is there no solution?
Because they don't touch
They're
at all.
parallel. Therefore, there's no.
No
They
intersect.
never cross.
Okay, now, when you get to the upper level, okay, you get to the level that I'm at, that upper level, I didn't have to graph because I already knew what the slope was of the first one, which is -1, right? What's the slope of the next one? It's also -1. If we have the same slope, we have parallel lines.
But the y-intercepts are different, and that's one thing you do need to kind of watch for. If they have the same slope, you got to check the y-intercepts. Because if the y-intercepts are the same, and they're the exact same line, then it's
we
this
have a
case.
problem,
Okay? So we'll call it a day. We'll skip on number 7. They're in those little puzzles, okay?
I think we're gonna do
All right, in those little puzzles.
If you wanna try that, if you want, we're gonna do more work.
Go to puzzle 2 in 13 minutes. Go to puzzle 2.
With this one, it doesn't say x equals.
Go to puzzle 2. Let me see your puzzle 2. Hang on one second.
Yeah. We just gotta comment.
Get these puzzles out. I'm going to make your life a little bit easier, okay?
Okay, we'll talk about it next time. Okay, you need your white puzzle.
Oh.
The break is happening after this. I'm going to shorten your homework, okay? This is homework.
So your white.
We're going to do the puzzle packet. Puzzle 2 is today's lesson. And let's do M,
I don't think so, no.
R. I should probably look at the answer key before I do all
Wait,
this.
did we just like, I think C, use these equations of.
You think C? Okay.
I don't want
And let's do one more. Let's
How about
do
A.
Let's
I have
do
stuff in your-
S. S. Okay? So these 4 problems are the ones that I want you to get done. If you want to do all of them, fine by me. I've got an answer key to all of them. But those are the 4 that I'm going to ask you to do. Okay? M, C, R, S. Hey, M, R, S, C. Mrs. McCartney. you remember. Okay? All right, that's what we're working on now.